Ladies and gentlemen, good morning. Happy Monday to you all. Ahoy. Reminder, I will not be here tomorrow. Okay. Any makeup tests must be done by Friday. At this point, if you have anything out, and I don't know in this class who has anything, but if you have anything out, then you got to take it during class on Friday. Okay. So check the grade book, see if you have anything out. If not, then you're good. Let's see. What else? Letters by next Friday?
Yes. Yeah.
Okay. What else? That's mostly it.
Mr. Hendrickson's Christmas gift by next Friday? No?
Jeff? Yeah, somebody decided to fire a stink bomb in the 6th-hour class that's in my room.
Thank you. You're the best.
This is a much better classroom here.
I know, he's going to be out next year, and this is going to be my room next year. So
Where are you going?
he's going down to my room, the stink bomb room.
What did they do there?
I know. Do you remember how I talked about the bubble?
No.
No.
You guys in the honors groups.
Oh, that bubble.
Oh,
Yes.
okay.
I've talked about the bubble?
Yes.
Okay. Stay
Wait, they're in a bubble?
Yeah.
You get outside of the bubble, the world is different. And most likely not a world that you're used to dealing with and things like that. Stay in the bubble. That's the best I can say. Okay? All right, homework. Go. This is weird. I have to look at everybody like this to kind of get you guys straight on.
They can move the desk.
Oh, I don't know.
Back.
Everyone from this side just
I'm laid back, I just, whatever, nothing matters. I prefer my room not to be stick bomb, and I'm going to be lucky about that in terms of what goes on during class. We'll be fine.
Okay, I'll be right back.
You want me to move this probably then, so that you can.
Probably, but
Whoa.
Yeah.
just put the pictures up, let everyone see.
Okay, questions? I brought my book. Where did I put it? I must have put it over here. Ooh, I put all my stuff over here. Nothing there. But that's... All right. Anything? Is the no hands going up or no verbalizing, meaning we don't have any homework questions to go over?
No.
Okay, fine by me. Then we're moving on?
Yes.
Okay. I like today's lesson too. So.
What is today's lesson on? Or what?
Today's lesson is on math.
I meant like what is it? What 12 point is it?
12.5. 12.5a today. 12.5a today. Remember that tomorrow is just going to be a work day for you guys in class. I've already put it on my note for the sub and everything, so they know, just to let you guys go. I did ask the sub to kind of keep people on task, not just sit around, twiddle your thumbs, and say, I'm going to do my work at home type of day. So let's not do that. Let's make them actually, get them to do something. Okay? So if that was your plan tomorrow to say, I'm actually not going to do anything and I'll do stuff at home, the sub's going to get on your case a little bit. Okay? Just as a heads up. Let's say that you were asked to do that, to expand that. 3x minus 4y to the fifth. Would that be easy, medium, pain? What would it be? How would you do it?
Square, double square, twice.
So we can't just do 3x to the fifth and 4y to the fifth? No. Okay, bummer. So we'd have to do 3x minus 4y squared, so double square it. And then we'd have to multiply it by 3x minus 4y. And then we'd have to multiply it by 3x minus 4y. That sounds like a pain. Yeah. And that's what some mathematicians a long time ago said also. And so they decided, they came up with a way to make it work that wasn't having to write all of it out. I mean, you know, we say the fifth power would be a pain. Think about like the ninth power or something like that. Yeah. So they came up with something that they call the Binomial Theorem. And basically, as we go through this, you're going to see our goal is so that you can see how we would take something like that, crank it out without having to do all of that grunt work, if you will. So, binomial theorem has a couple different parts. First thing that we will talk about dealing with the binomial theorem is what we call Pascal's triangle. You will never, ever guess who invented Pascal's triangle.
Pascal.
Holy cow, you got it. Blaise Pascal is his name. He invented Pascal's triangle. So, Pascal's triangle is a triangle of numbers. Okay? So it starts at the top at the peak with a 1. And then after that, each row will grow by one number. So the first row, this row has 1 number, the next row will have 2, the next row will have 3, and so on and so on. Each row will start and end with a 1. Okay?
I think the geometry teacher had this written down on the
Maybe.
board.
Could have been. And then if you end up where you're going to be putting a number between 2 numbers above it, you add those 2 numbers. With me at all? Yeah. So the next row will have how many numbers in it? It will have 4 numbers. This one already has 3.
Oh, yeah.
So the next one will have 4. It'll start and end with a 1. And then that'll be a 3. And that'll be a 3. Does that make sense? So what about the next row? Starts and ends with a 1. 4 there. You said 6 there. And you said 4 there. Cool. What about the next row? Start from the left and go work to the right. 1, 5, 10, 10, 5, 1. Perfect. How far could we go with this? As far as we need to. Yep, we go infinitely. And that's Pascal's triangle. Questions with that? Yep.
I'm sorry.
Huh?
I don't understand.
Well,
So like.
you're not going to
I know,
understand
but, like,
the use of it yet.
Yeah, but like, how did you?
Okay.
It's like,
Okay, so we start and end with a 1. And then this number here is between these 2. So we just add them together.
oh, okay.
And then this number here is between these 2.
Oh, okay.
Better?
Mm-hmm.
Yeah.
Why is it all like, why does it start
The y's of Pascal's triangle, I'm not sure you want to ask at this moment. Well, my point is that we're kind of going to see it a little bit in a minute. But to be honest, the y's don't really matter for this because you're just going to use the numbers at some point. So give me a couple minutes. Let's see if we can answer the y's. And if we don't answer the y's, we don't really care. Which sounds bad, but you'll see. Now, as we move on, you're going to find that there are, that they might ask us to get some numbers way down on this triangle. And so again, people said, well, I don't want to, I mean, do you want to write like 20 rows of this triangle? Of course not. So they came up with other ways to make it work. But before I go there, I gotta mention this. This is called row 0. So the first row is row 0. And then comes row 1, followed by row 2, followed by row 3, etc., etc. Okay? So it starts with row 0. And each row, by the way, starts with element 0, or term 0. So this would be called term 0, this would be term 1, term 2, term 3, term 4. Okay? Trust me. But, like we said, we may not always want to write out all of Pascal's triangle. And so another way to get some of those numbers, you're going to see it asked this way. You're going to see it written something like 5, 3, inside parentheses like that. Okay? The generic version of it will be NR, N on top, R on the bottom. And the formula, if you will, for this NR thing is N factorial over R factorial times N minus R factorial. That's kind of our formula. You'll hear this later on referred to as a combination. So if anybody has dealt with permutations or combinations before, that's what this is. We're going to see it a lot more coming up next semester. You know, by the way, that Friday is the last new material of the year. So anyway, I'm sorry. So 5, 3. Some people say 5, choose 3. How would we write this? 5 factorial over 3 factorial times 2 factorial. One of the things that you'll notice pretty quickly is that these two numbers on the bottom, not the factorial part, but these two numbers on the bottom will always add up to be the number on top. Okay? So you'll write this number and then basically subtract them and put that as the other one. Now, how would we simplify that? Well, how can we write 5 factorial? 5 times 4 times
3 factorial.
3 factorial. Why would we want to write it as 3 factorial? Because on the bottom we have a 3 factorial. And then this would be 2 times 1. This will always work. This is I kind of like this. This is kind of cool to me. The number of terms on the top and the number of terms on the bottom will always be the same. So for me, it's kind of a check thing to make sure I'm doing it right. If I'm getting different numbers of terms on the top and on the bottom, then I messed up.
Are we not allowed to multiply 3 factorial times 2 factorial?
Well, let me ask you this. What is 3 factorial? 6. What is 2 factorial? 2. With me at all here? And so if you said 3 factorial times 2 factorial, that's certainly not 6 factorial or anything like that. You know where I'm coming from? Yeah, so you can't multiply factorials in that regard. Okay, what can we do now? Cancel. 3 factorial takes out the 3 factorial. Anything else? 2 goes into 4 twice, which leaves us with 10. 5 times 2 is 10. seeing something here. Row 5, term 3. Remember, the first term is term 0. So term 0, term 1, term 2.
Well, you didn't tell us that that's how it is, like row 5.
I know I didn't. I saved that for now. I wanted it to be a surprise.
Oh, okay.
Wait,
Waiting.
what's the problem?
We're getting there. This is the beginning of it.
Okay.
Okay? So this is a way to get a number in Pascal's triangle without having to draw out the whole triangle. You know, you'll see something, and we'll do some more of this on Friday, but you're going to see this stuff on your homework tonight. So I wanted to make sure I went over it. But you're going to see stuff like, 10, 8 on your homework, which would be finding row 10, term 8. Yeah. And then this would be 10 factorial over 8 factorial 2 factorial. Does that make any sense? 10 factorial would be 10 times 9 times 8 factorial over 8 factorial times 2 times 1. 8 factorials cancel, 2 goes into 10 5 times, 9 times 5 is 45. And so you know that row 10, term 8 is 45. And you don't have to write out 10 rows of Pascal's triangle. Row 2, row 3, row 4, maybe even row 5. Absolutely, I can see running out Pascal's triangle. But row 10, not doing that. Okay? Questions there? So then the question becomes, why? And that is a good question. We're not going to get to this yet. We'll get to this. We may do it more on Friday, but I need space, so I'm erasing that. And we're going to do this. We're going to start with x plus y to the 4th power. Does anybody know what the first term of x plus y to the 4th power is going to end up being? X. 4th power. Yes? First term to the power. So first term to the power is our first term. Okay with that? Now, after that, for the next term, oh, and by the way, what power of y is here, is in this term? I know it's not
0.
there, so what power is this?
0.
0. So could we have written x to the 4th, y to the 0 here? Sure, why not? From then on, each successive term, this power of the first term is going to drop by 1. And the power of the second term is going to go up by 1. So the next term is going to be x to the 3rd and y to the 1st, exactly. And we're going to keep going with that. So the next term would be x to the 2nd, y to the 2nd, and the next term would be x, y to the 3rd, and the next term would be y to the 4th. Questions on that? Logical? Yeah. Okay. How many terms do we have, by the way? 5. Does that make sense that we would have 5 terms on x plus y to the 4th power? Why? It's always 1 greater than the power. What about a square? What about like x plus y squared? How many terms does that have? 3, because it's a square, double square, right? So if we have something squared, we have 2 terms. Yeah, good. We have something squared, we have 3 terms. There's always one more than the power. What if we had x plus y to the first? How many terms are there in x plus y to the first? 2, x and y, right? So first power, 2 terms. So it's always one more, okay? What do you think we still have to put in? Signs and, heard it, coefficients. Coefficients? Don't all of these polynomials tend to have coefficients? Okay, ready for this? Here you go. Okay. 4th power. 4th row. Guess what these numbers represent? The coefficients. 1 plus 4. What's next? Plus 6. Plus 4. Plus 1. And that's x plus y to the 4th. Well, that's kind of cool. Something what? You said you love it? Is that what I thought I heard?
Yes.
Well, but why do we do this? Well, what would be easier? What we just did, or multiplying x plus y times x plus y, getting the answer, multiplying that result by x plus y, getting that answer, multiplying that result by x plus y. Which is easier? This is much easier. Yes, sir?
So like, you said like, when the people made this, like if they had like x plus y to the 9th, would they draw out a Pascal to the 9th, or they just find these shoots out?
They might do this. They might have done Pascal's triangle.
For all of the terms.
What we're going to do, not on tonight's homework, but on Friday night's homework, what we'll do is they will ask us for the 4th term of 3x plus y to the 9th. We'll talk about that more on Friday.
So is the triangle always the same numbers?
Great question. Pascal's triangle does not change. It's not, well, if it's this, then the triangle is this, but then we might have to alter. No, this is Pascal's triangle. If you look anywhere in the world for Pascal's triangle, you will see exactly the same numbers all the time. There is no adjustment made to it. So that was cool. Thanks. Okay, so yeah, that's it. So those will always be the coefficients. That was good. Questions there? All right. So we have a little bit of an idea what's going on here? Okay, then what should we do?
Try practice.
Make it harder.
Yeah, sure.
What would make it harder? Let's see. How about
Minus.
3x minus 2y? Should we go to a 6 on a scale of 1 to 10 or an 8 on a scale of 1 to 10?
6.
7.
No, I can't go 7. Either 6 or 8.
6.
8.
8.
What?
Let's go.
Eight.
8, because then we don't have to do 6 and 8.
Yeah, I like 8. So 6 was 3.
That's level, that's 8. If we had gone to 6, it would have been a 3rd power. We're better off doing it this way.
That's my new
Okay, so remember what we said the first term was here.
First term is power.
It was the first term to the power. What was the first term in the parentheses? X. What's the first term in this parentheses? 3x. So the first term of our answer, and you're going to need more space to do this one. Okay? Just longer, not like crazy amount, but longer. The first term here is going to be the first term, which is 3x to the 4th. Does that make sense? You're going to use a lot of parentheses here. A lot. Not like nested parentheses, but it'll be parentheses, parentheses, parentheses. There will be a lot of parentheses. Yes, sir?
How do we, use the coefficients?
We'll do the coefficients at the very, very end. So what we'll do first is we'll set up the terms like we did here. Okay? So we did the first term to the fourth power. Is that all that goes in this? Basically, yes. We'll get, like I said, we'll get coefficients at the very end. So now for the second term, what goes in the second term? 3x to the third, and do we take the negative? Yeah, the minus is part of that term. So the second term in the parentheses is minus 2y. So we'll do minus 2y to the first. We okay with that? All right. Tell me about the next term. 3x squared. Negative 2y squared. So you're seeing the pattern here. Is the pattern a really difficult pattern to follow? No, just keep going up by a power and going down by a power. That's it. What's next? 3x. Negative 2y to the third. And then negative 2y to the fourth. Are we okay with all the terms there? Are there questions on the terms? Okay. What do we need now? The signs are going to work themselves out. You'll see that in a minute. So don't stress about the signs. They'll work themselves out. What do we need? We need coefficients. Where do we get the coefficients? Pascal's triangle. What row do we use? Why do we use row 4? Because the power is 4. Okay. Row 4. Talk to me. 1 plus 4 plus 6 plus 4 plus 1. Okay. Questions on what we've done? The entire rest of the problem is just simplifying. Now, that being said, the simplifying part is by far the place where you're going to make the most mistakes. There are little mistakes to be made everywhere. So, I strongly suggest that you take your time and show each step. You don't want to go straight from here to the answer because you will make mistakes. Okay? So, I'll show you how I would do it. I'll show you how I do it. What, I said do?
How so funny?
It's kind of like my room right now, right? This is how I do it. You know I'm lazy. You know I'm going to take every shortcut I can. There are too many little mistakes to be made here to try to shortcut it. So, 3x to the fourth power. 3x to the fourth?
Yeah.
What does this mean?
3 to the fourth.
It means 3x times 3x times 3x times 3x, which becomes 81. What's the easiest way to do a number to the fourth power? Square it, square it. You got it. Are we okay with that first term? Okay. For this second term, and for all of the rest of the terms, I'm just going to simplify that power. The only thing I'm going to do from here to here is simplify the powers of the terms. So I'm going to keep the 4, then 3x to the third. 27x cubed. Fair? Times negative 2y. Questions there? Are you grumpy?
I'm just confused on why we're doing the power and keeping the power.
Well, okay. This is saying that it's 3x to the third power, which means 3x times 3x times 3x. So we got to do 3 times 3 times 3. And then we have to do x times x times x.
Got it.
Better? Plus 6 times, not 6, 9x squared times 4y squared. You see what I mean about this? It's not hard, but it's so easy to make mistakes. Plus 4 times 3x times negative 8 y cubed plus 16 y to the fourth. Ooh, that's a mess.
Next step.
And now, okay, a little bit of much.
Words.
You can probably see the reasoning behind this intermediate step. Okay, because I don't want to try to do 3x to the third and then times 4 and then times negative 2 all at the same time. The chances of making a mistake, a silly mistake, are, like I said before, off the charts high. So write this intermediate step. You're not going to have a ton of these to do, so just make sure you do them right. So, 81x to the fourth. What are we multiplying together here? 27 times negative 2 times 4. Okay, so we have all three of these numbers we got to multiply together. 4 times 27 is 108. Times negative 2 is negative 216. X cubed y.
So we just put those together?
Yeah. What's x times y? Yep. Okay, now 6 times 9, 54, 54 times 4, 50 times 4, and 4 times 4, added together gives us 216 again. Oh, interesting. No.
Wait.
Are we gonna be able to?
No, we're not.
Wait, how does this?
How does what, huh? 6 times 9 is 54, 54 times 4. So think of 50 times 4 and 4 times 4. 216 x squared y squared minus, I would agree,